So to highlight this a little bit more, what I'm going to do is I'm going to start with this is where we're starting. I'm going to start with a blank coordinate system, and we're just going to focus on T1. This is our mass M still. Oops. This is T1. And I'm going to draw it with a dotted line because what we are more interested in right now is the projections that we've just defined. And remember, I said that there's this triangle, again we'll just draw dotted lines, that we created right here. Okay? And it's a right triangle, and we said this was magnitude T1. This is T1 sine theta. This is T2, T1, whoopsies, cosine theta. Okay? To this point right here. Now, I think it's kind of easy to see the first one that I'm going to take, and that is that there's now this length acting in the x direction. Okay? And this is what we're going to call the x component of force T1. The trickier one to see is I'm now going to take T1 sine theta, and to show you this, I'm going to erase T1, and I'm going to move it this way. And you'll see I can now draw another force on my y-axis of the same height, T1 sine theta. Okay? And now I've taken that force F that we initially started with, or not F, T1 that we initially started with, and I've broken it in to two components. Now if we remember anything, and I know most of you probably haven't done any vector calculus yet, but if we vectorially add T1 sine theta and T1 cosine theta, what we'll find is they create a vector, which is our force direction, T1 cosine, theta I plus T1 sine theta j. For anybody who really wants to look it up, this just means this is the magnitude of the force acting in the I direction, I hat direction, which is a fancy way of saying the x direction. And this is T1, the magnitude of the force T1 acting in the j direction, which is another fancy way of saying the y direction. Okay? So, with this, we've defined T1 exclusively in the x and y direction. So I'm going to erase, no, I'm not going to erase T1. So the process is exactly the same for, the process is exactly the same for our component, for our force vector, oopsies, not left-handed, it's going to be tricky, our force vector in the T2 direction, right? So I drew this right triangle, and I said that now, boom, this has a component here, T2 cosine theta, because we said theta was the same for both of them. And we also have equal one here. So now we have two forces acting in that y direction. Now I'm going to erase this, not because it doesn't exist, but just for clarity. So I got this guy here, and this guy here. And they're both acting in the positive y direction. Right? So this is no longer here. And this one is T2 sine theta. Okay? give you a little better view of that. What I've done is I took T1 and T2 and I created projections onto the X plane and the Y plane, axis, I'm sorry. And so if we erase these, what we'll find is the magnitude of these forces is equivalent to the magnitude of these components is equivalent to the magnitude of the force, the total force vector that they represent.